This is something I call the true history of Ball and Urn with Sogrates and Amphibianes. You will play the part of Sogrates.
And Amphibianes plays the part of himself.
Through painstaking research, I have traced the beginnings of the ball and urn analogy to ancient Greece. I have discovered a lost manuscript about the greatest philosopher of all time. Though long since forgotten, at one time he was so great that people called him Sogrates. This manuscript describes a dialogue between Sogrates and one of his students, Amphibianes, who was always hopping all over him with questions. Throughout the following reconstructed dialogue, notice how Sogrates employs the Socratic method, by which the student is brought to knowledge through queries such as, "What's so great about that?" Remember, you are playing the part of Sogrates, and Amphibianes is playing the part of himself. I will help you with the Sogrates part, but please read along.
Oh, great Sogrates, I want to learn the secrets of combinatorial analysis.
Combinatorial analysis, tadpole, is just a fancy way of saying how to count.
Count? I know the count. Should I ask him?
No, by count we mean a way to number possibilities. Here, let's try an analogy.
I flunked analogy in high school because I refused to dissect frogs.
No, an analogy is a situation which helps you understand something better.
Okay, but I won't dissect anything.
Suppose that you have 6 balls and 3 Greek urns.
What's a Greek urn?
It depends on the minimum wage in Athens. Anyway, how many ways are there to distribute the balls into the urns?
That depends. Can I tell the balls apart?
Yes, suppose the balls are distinguishable. We'll number them 1 through 6.
Distinguishable? You mean they are easy to put out if they catch on fire? How about the urns? Are they distinguishable too?
Yes, let's label them Athens, Boeotia, and Corinth.
Sounds as easy as ABC.
So you have 6 balls. Each one has 3 choices of where to go. So how many possibilities are there?
It must be 3 to the 6th power.
Correct, oh bug-eyed one. What if we have B balls and U urns?
Then B takes the place of 6, and U takes the place of 3, so it must be U to the Bth power. Will that always be true?
I guarantee.
Okay, but what if the balls were not numbered and you could not tell them apart?
You mean they are indistinguishable?
Like my college transcripts.
Okay, suppose that all the balls looked the same and were not numbered, but the urns were still labeled.
You mean if I had 3 balls in A and 2 balls in B and 1 ball in C, and I switched the ball in C with one of the balls in A, I couldn't tell the difference?
Precisely. This is a more difficult problem, no?
Whoops! I knocked them over. Now I'll never earn a place in history by solving this problem.
Oh, but you're wrong, oh Croakmeister. You don't need the urns to solve the problem. They are only props.
Yeah, right. I suppose I could just put the balls into 3 lineups with 2 spaces between them and just imagine that the urns are there and everything will be just ducky.
There is no need to use foul language. Yes, this will work. Just ponder the problem a little more.
Okay. I'll try not to leap to any conclusions. Now I can think of the problem as a lineup of 6 balls and 2 spaces. How many ways can I arrange 8 items, 6 indistinguishable balls, and 2 indistinguishable spaces?
I'll give you a hint. Mississippi.
Yes, a great vacation spot if I say so myself. Oh, you mean 8 factorial over 6 factorial, 2 factorial.
Or you could think of it as selecting 2 positions for the spaces from the 8 possible positions, and the balls must be put in the remaining positions.
Then it's 8 choose 2 or 8 choose 6. They're the same.
Yes, you have found the missing link.
And so a general solution has evolved.
You mean you can handle B balls and U urns?
Naturally, since 6 balls for 3 urns can be interpreted as 6 balls in 2 spaces for a total of 8 to choose from,
then B balls for U urns can be interpreted as B balls and U minus 1 spaces for a total of B plus U minus 1 to choose from.
And since I picked the positions for the 2 spaces and the balls go in the remaining spots, or I can pick the positions for the balls and the spaces go in the remaining spots.
You could pick the positions for the U minus 1 spaces and the B balls go in the remaining spots, or you could pick the positions for the B balls and the U minus 1 spaces go in the remaining spots.
Our general solution has evolved. Either B plus U minus 1 choose U minus 1, or B plus U minus 1 choose B.
So now you have an analogy anytime the urns are distinguishable.
Wow, this is cool. I can't wait to tackle the case where the urns are indistinguishable.
Well, first you have to know a little about derangements.
Like my Uncle Toad?
No, a topic which we will save for another time.
Oh, thank you, Sogrates. I can't wait till the next opportunity that I will have to use this newfound knowledge.
So, that is the true history of combinatorial analogies. Honest.